added some other outputs in the course of this, in the course of calculating friction factor into the friction factor calculator. We added random number, fluid velocity, pressure drops in feet or meter, then the other one in pressure drops in PSI, that's pounds per square inch, or in kilo Pascal. So in order not to waste your time, I added these labels and text boxes into this output frame. So what go straight to the point. And again, I also use this medium, this part 3 of this series, to also highlight the difference between Enum and constant. Using Enum to represent constant values in an equation. Now let me go to this. So this was what this was what the codes were. These were what the programs were when I started this. This was where I left it in part 2. So I use Enum here. Now let me press F8. Let me use F8 so that you get to understand what I'm just saying. Now let me select this, press F8 again. Now let me come here, select the form. Here is one. Let's say here is one kinematic viscosity. I'm still using the parameters of those equations that we solved. So this is 57. Sorry. Here is 57. That is 5700 gallons per meter. This, the specific gravity is 1. The absolute pipe roughness is 0.002. The pipe diameter is 20. The pipe thickness is 0.375. The pipe length is 2500 feet. Now let's see, calculate. I'm now go through. Now, I haven't gone through this levels. Let me now stop here. Go to the Enum. Now, see this one, the customary unit here is 92. See, it deletes between the 4. So with this effect, your answer, if you use this to calculate, to impute in your formula, your answer will not come out correct because of this small reduction. Okay, let me go further. Let me just go further. You understand what I'm saying. Now let me close this and create a function for velocity. Because velocity is part of this. Velocity is part of this. So now let me come here. Let me call it fluid velocity function. click enter. Now I'll say wait from say end wait. Now for velocity, I will now say if I will use the if function here. If does 0 TP, so 0 sorry OPT brackets open and close 0 index 0 dot value is equal to true, then now let me go down and end if statement. So now come here, say if this is 6, we'll now say fluid velocity is equal to, now is equal to, let me come here, I have this for, copy, this is for customary. Let me paste it here times flow rates divide by internal diameter square, internal diameter raised to power 2. Now there are many of these, so I want to use enum too. I want to change this to enum, so using enum to represent this. Now let me now create another enum. Now for me to do let me differentiate this. Let me call this unit conversion for Reynolds. Then here call this Reynolds. Reynolds. Can just copy here, copy, paste, and paste. Now I've made that change, so let me come here and readjust the change. Okay, it has readjusted itself, so let me leave it at that. It has readjusted itself. Now since we have called index, next what I will do, I will now create the enum for, I will now say public enum. It's a units conversion, say velocity, conversion, velocity, and enum. Now let me copy this. I will not delete this. Copy this, paste. Now copy. Okay, let me make this one fluid velocity. So then I copy the fluid velocity. Then select this and come to edit, find, replace this. Select this, select merge. Now select where I want to replace. So replace all. Have this. So it's replaced now. Now I wanna go to here. I'll copy this for customary units. Change this to this. Go here again. Copy this for English units. Copy. Come here, change it to this. Then go back here. Copy this for SI units. Paste. So now wait. So I've gotten this. Now I cannot replace this. So let me just say customary. Customary. Let me say unit conversion, fluid velocity dot fluid velocity customary. So this is so, but this, let me change this to. Let me check this. Let me use. I need to add this to this. So unit this Renaud dot customary. So come here, units this Renaud dot English, Renaud English. The same here. I'll change here now to units Renaud SI unit. So this is done. Sorry. This is done. Now can I complete this? Let me see. You have this. Okay. Okay, then this, so I will now, what I will do now is to copy. Okay, so copy this, come here, write S, paste, change this to 1, change this customary, change this customary to this. Then now copy the whole of this, copy this, paste it here, change this to 2, change this to XI units. Now let's press F8 again. Now select this, press F8 continuously again. Come here, select this, say 1, kinematic viscosity 1, the fluid legal per minute is 5700, the specific gravity 1, the absolute is 0.002, the pipe thickness is 0.20 diameter, this is 0.375, the pipe thickness, then the pipe length is 2500. It's 2500. Then I will now click the solver button. Go. So now, if you go to this, the constant here, this is 0, this is 0, this is 0, this is this approximated to the nearest whole number. You see, this will give you a wrong, absolutely a wrong answer. So let's continue. Look at it now. To give you absolutely a wrong answer. So it shows that this does not give you a better solution to what you should do. So what I advise we use, okay, let me go here, reference, so now let me reference that function there. Txt to get velocity. Let me see, txt fluid velocity dot text is equal to property equals fluid velocity brackets open. fluid velocity brackets property dot flow rates comma property dot internal diameter close. So now let's solve this again. Let's look at it again. This is 1, this is 5700, this is 1, this is 0.002, this is 20, this is 0.375, this is 2500. So I click this. Let's try again. There's an error somewhere. So let's look at where the errors are. So looked at this, okay, this is correct. Let me look at the class module. Okay, here I didn't specify, I didn't define this flow velocity. I didn't define it properly, so I will need to put the independent variables. So I will express it as double, then put the independent variables of this function, which is the flow rate, and internal diameter. Now let's check again if I believe this will solve the issue. This will solve the problem. That was why it was showing a mismatch. Because the function I specified in the module has variables, while the real one where the thing is coming from doesn't have variables. So I believe this should solve the issue. So this flow rate 5700 gallons, specific gravity 1, the absolute roughness 0.002. Outside the pipe diameter is 0. See, the fluid velocity gave us 0. This shows that the Enum knocks off the decimal parts, which is what I've been explaining. It knocks out the decimal parts. Shows that the Enum knocks off the decimal points. It make the naturally it will be showing that fluid velocity custom unit is 0, fluid velocity English unit is 0, the fluid velocity SI unit will be 354. The nearest whole number. So this shows that Enum is advisable to use it when your constants, when your values that you want to express there is completely a whole number. I need to close. Okay, I didn't stop the program. Let me stop the program. Now go back to. I want to create constants now. So private constants. Private constant. After I copy this, I can first copy the first one, the customary units. Paste it here. Give space. Paste it there. So that will give me that. I'll copy this constant I've created. Then I paste. I'll create the other constants. Then I'll copy the English ones. Replace this other one with it. Replace the customary with it for the second one. And then the SI units are copied. Replace it with this. So I'm done with field velocity constants. I'll delete the Enum, and I'll do that for Reynolds number. So what I'll do, I'll copy the field velocity, copy the whole of it, the field velocity private constants. Then I will use the Reynolds customary, Reynolds English, Reynolds SI unit to replace it. But if I'll do that, let me go and make changes to. So let me copy the whole of this, okay? Let me copy, enter twice, paste, then I replace the Reynolds customary units. Copy it, replace the flip velocity customary unit with Reynolds customary unit. So I'll do same to the respective position for the flip velocity. Replace it with Reynolds of its counterpart. So that is what I'm doing right now. So I've done that. I'll delete the Enum. And that is giving us, we're not giving us the right listing. So having done this, I will now copy this, create the acceleration constants to acceleration. But what I'll do, I'll use find and replace. So use Reynolds, go to edit, find, click replace, type acceleration due to gravity. And go select the part I want to change, then select text, match case. Go to release all. So I've made the changes. So I'll close this dialog box. Then I need to change this to 32.2. There's also the same value, 32.2. Then this one is 9.81. For the SI units. So I go down to the Reynolds. I need to change the whole of this, the Enum expression there to constant. So I'll type Enum and select the Reynolds constant units, Reynolds constant units. And I'll select this one for the English, for Enum English. Replace it with the constants Reynolds English. So I'll delete the whole of this, type arrow EY, and then select Reynolds English. I'll do something to this, delete it. please alter space bar, select Windows SIS, okay. This part is done. So I'm going to the velocity side, change the enum to the constant. There is a fluid velocity customary. Fluid velocity customary units. Also change the English units. The enum relation to fluid velocity in English units. Also change the enum SI unit to fluid velocity SI units. So that I've solved the issue. Save, click, run icon, then I'll type 157,000 for specific gravity. Absolute pi, roughly 0.0. Outside diameter 20 basic. So when I click, you see, okay, I didn't select the English unit. When I select the English, it gives me fluid velocity 6.28. So I need to round it up to 2 decimal place. So I'll go to the module. Close. Go to the module. Type random bracket open, then comma at the end, type 2, bracket close, enter. So now run it again. Kinematic viscosity 1, flow rate 5700, specific gravity 1, absolute pipe diameter reference 0.002, outside pipe diameter 20. What you can see, calculate English units. This is 6.28. So this is right. The minimum number is 93, 9.5688, which is correct. You can also change the flow rate to 4 decimal place. Go back to the class module. So okay, I use format here. So what I'll do is to reduce it to 4 zeros, 4 decimal zeros. Okay, save. I need to save it. Okay, then run it again. This is okay, 0.002. This is 20. This is 0.375. This is 2500. And save. Okay, no. Then solve to give me 0.0136. This is 6.28. But you see, if it's with the enum, I had 0 here. But for constants, it gives me 6.28. So you can see what I'm saying. In some cases, you should use enum. In some cases, you should use constant. So we need to create the pressure drop functions. Click. No, I need to select the function, then click OK. Close the space there. With the form address, let me show a different function type where you don't put variables, you don't put independent variables. The one for the flow velocity, there are independent variables. So this one, there will be no independent variables. Although I can put independent variables in this, but I want to use this kind of functions in the class module. So let me open a notepad document that I created for pressure drop. I'm looking for the formula for pressure drop. Let me just first type with the form address and end with. Then let me copy this one for the flow velocity, the if statement for the flow velocity. Let me copy that one. Use it to edit the pressure drop. So let me use it to edit the pressure drop. I paste. Let me paste. Okay, sorry. Paste. Okay. This is select the velocity. Go to edit find. Should type in pressure drop, pressure drop. As a function, then copy this, copy, then copy, then select the fluid velocity. Select fluid velocity, go to edit, find, click replace this with pressure drop. Then select the area of the changes, which is this. Then do select this option, then match case, click OK. Click replace also. And that has been done. So what next I will do is to edit the formula by opening the formula for pressure drop. So now I also need to create the constants for pressure drop. So select Reynolds, find, edit, find, replace, click replace button. Okay, pressure drop is already there. Select the area you want to do. Okay, what else? So click the changes as well. Carry out. So I created the constant. So I want to replace these values there. So let me open the notepad documents that I created. Scroll down. Okay, it's not this one. It's not this one. this. Okay, is this one. Is this one. This is the Darcy West pack. These are the constants for change it to 2.31, the same value 2.31. Then this one should be 0.102 for the SI units. Then the customer units and the English units is the same. It's the same because the heads in the pressure drops in heads are fits they are the same. So we are using Darcy Weisbach equation, which is the head equal to friction, which is just, I will now say the friction factor as the I will say friction factor equal to T equal to dot TXT for friction factor dot TX I need to change this to text to value by clicking VAL bracket open, and at the end I put bracket close. So I'm changing the string to value. Changes to friction factor. I want to delete all this. The constants are not here. Changes to friction factor dot times bracket open and close pipe length, select pipe length divided by internal diameter. Then we have to change pipe length to inches, because the internal diameter is inches, so by multiplying by 12. That's the same. Times bracket open close at the end. So let's go back again. Inside we see if we use C square times C. So delete this whole thing, replace it with fluid velocity. So pressure drop. Put the decimal number of decimal place. Let's see. So select the pressure drop, place kilopascal. Equal to, this is where we use those constants. So we go and check the equation. Let's round it up. This one I should round it up to 2 decimal place. So I'll go back to the notepad to check the check the formula. Pressure head is equal to this constant times perspective. So what I would do is to times by specific gravity, then divide by that constant, divide the whole by that constant, which is pressure comma. I need to introduce comma. Then I say 2 decimal place, get about 2 decimal. Okay, close. So we'll copy this and edit. Copy this, replace this one once in English and assignment. I'll make addition, we'll edit them. So select this paste what I've copied. Then I need to edit. I need to change this customer to English. Customer to English units. Select English units. Then change the constant down here, the pressure drop customary to English. And then select English. That is that. I need to edit the assignment too. So I'll replace this with what I've copied and change the customary to SI unit. Acceleration due to gravity SI unit. Correct. Then change this one, pressure drop customary to pressure drop SI unit. Select XI unit. Good. That is that. Done with this also. Then I need to go to the module, add the function. To add the function there. I need to add the function, which is pressure drop dot, which is property dot pressure drop. Okay. Pressure drop. That's that. This will direct it to where everything that you need to solve will be solved. So let's select English. Kinematic is 1, the flow is 5700, the specific gravity is 1, this is 0.002, the diameter is 20 inches, this is 0.375, the pipe length is 2500. What is the problem? Okay, let me copy. I didn't completely specify because this one has variables, independent variables. I need to copy from the function, copy the fluid velocity with independent variables and paste and replace this with this. So that is the issue. So I replace all of them with them. Replace text with this. Go back. Okay, I think it's solved. So we have pressure drop. This is 12.99. For feet, pressure drop in feet is 12.99. Then pressure drop for PSI you have 5.63. So this is great. So it shows that the pressure of constant has equal 0. If it's for this other one, this other friction factor calculator that I use Enum, when I open the one and I use Enum, which is this right here, I use Enum, you see that the pressure drop in feet and pressure drop in PSI is completely different because those values, the pressure drop, the Enum, we just choose 2 instead of 2.31. So that is why. Okay, no, let's choose English unit. So click. This one gives us 13.06 for pressure drop in feet. This shows that the 2. You're dividing the formula. You divide by that constant 2.31. So the Enum is just choosing only 2 there as a constant. For this one, the constant value will be choosing 2.33, then 31. But for the Enum, we only choose 2. Look at it now. Let me just this one I'm keying in now. Let's see. Friction factor. Calculate I'm keying in. Uses constant. Uses constant. You see the answer now. This one is 12.99 for constant because it uses 2.31 exactly. While this one uses 2, that's why the pressure drop is high for this case. But for look at this, the pressure drop for 5.67. This one is 5.63. This one is 5.63. We are solving English units. The English unit, the constant is a whole number for random number, so the issue will not arise. When we look at the code, you see that it's a whole number. So when we open the textbook where this question is provided to you, so I don't know back. So let me just save. Let me shut down. This is where the thing is gotten. This is the another number which is the same, which is correct with what I got, which is 9356.